Alright, so to help us out with our project here, we got Chris who's gonna walk to determine the speed of the observer, and we got Aiden just chilling in the warm car. But so we need to find the speed of the observer. So to do that, we measured out 2 parking spaces, this one right here and that second one. We found that the distance is 5.28 meters. So now we just need to find out how long it takes Chris to walk those 5.28 meters. You ready, Chris? All right, ready, set, go. Ah.
Hey, Chris, what you doing?
Trying to perceive the frequency of that car.
Well, I think you're gonna do that, Chris.
I'm gonna listen to it as it goes by.
Awesome. Well, Chris is gonna do this is that we're gonna use the Doppler effect. So actually, we've had a couple equations set up right here. And using these equations and the derived data, Chris is gonna find out what his perceived frequency is of the car. Pretty neat, huh?
Pretty neat.
Oh, hey, Chris, you practicing for track or what?
Yeah, I gotta get my vertical up.
All right, so what you trying to figure out?
I don't know.
Well, I'll tell you what you're trying to figure out. So, Chris, you're gonna be walking right past his car, trying to figure out what the frequency is that you're perceiving. So, just walk at your normal rate, and we'll see what happens.
It's cold as balls. What?
Yeah, it is. It is pretty chilly, Chris.
La mejor de todas.
How you doing, Chris? All right, well, taking the data we got out from the parking lot, we had the car going 5 miles an hour, which translates to 2.24 meters per second. Also, Chris was at rest, so the speed of the observer is 0, hence on top of the equation just 1. The velocity is always 343 meters per second because the sound or the wave was traveling through air, and the actual frequency was 106.9 because that's the radio station we got. Yeah. All right. So we're trying to figure out the perceived velocity, which is f1. So if we plug into the equation, we realize it's going to be 1, and it's minus because the car was moving at Chris. The speed of the, all right, so we got 2.24 meters per second over 343 meters per second. And we're going to multiply this quantity by 106.9 megahertz. And this, we'll get the perceived frequency to equal 108 megahertz. So this is what Chris perceived as the car drove past him. Alright, so the second experiment we did was we had Chris walk past the car moving 5 miles an hour. And we found out, we measured 2 parking spaces, and then we timed how fast Chris was walking across it. And then doing distance divided by time, we were able to get meters per second, which is 1.20, which is slower than the average human.
I wasn't even trying.
Alright, so the car was moving at 5 miles per hour, which as we said earlier, was 2.24 meters per second. The velocity started at, as last time, 343. And then this time we're listening to El Grande, 104.7.
Because he's Puerto Rican.
Some Puerto Rican. So, to get the perceived frequency that Chris heard walking past, we set up the equation. And since the car was moving towards Chris and Chris walking towards the car, it's going to be subtracting. So the speed of the observer was 1.20 meters per second over 343 meters per second. And that quantity over 1 minus 2.24 meters per second over 343 meters per second. And we take all of this and multiply it by El Grande. And this final answer comes out to be 105 megahertz.
So what is it? What does this megahertz mean? What does that mean?
That means that as Chris was walking by, he perceived the frequency to be 105 megahertz.
Nice.
Close to 1.47.
Which means Chris has
Way to go, Chris.
104.7. So that
Good
means
work,
it's
Mark.
Good.
Good work, Aiden.